Hello, I'm Jash. In this video, I will be running analysis and design on the same 23-story model which I prepared in the previous video under the load combinations of dead loads, live loads and seismic loads. So first we will define the seismic loads by going to define, selecting the load patterns, adding the seismic load, give here the name as seismic, the type as seismic. Here we will select IS 1893-2002. Click on add new load. Select the seismic load. Select the modify lateral load. Here the acceleration will only be there in the x and y direction only. So select the x and y direction only, as there will no eccentricity. Now we will find the values of these respective functions from the IS code. First, the seismic zone factor value from the IS code will be, wait, okay, so the building we are constructing is will be constructed in Bangalore. So the seismic zone for the Bangalore region will be zone 2, and the value of seismic zone factor for the zone 2 will be zero point 0.1 as shown here in table 2. So here we will select zero point 0.1. The site type will be, we are assuming the strata as a medium soil, so here we will select the type 2. The importance factor for non-public buildings will be 1 as shown in the table 6 clause 6.4.2. So here we will write the importance factor value as 1. Now the response reduction factor value. Going to the back to the IS code, the building we are constructing is an ordinary RC movement resisting frame, so the response reduction factor value in our case will be 3. So we will write here the value as 3. Okay, so now we have got the respective values. Now click on OK. Now click on OK as the seismic load has been added and been modified. Now go to the load combinations, whether the seismic load has come in the combination or not. Here we can see that the seismic load has been added in the combinations. So click on OK. Now we will run on the analysis. Wait as the analysis is being done. Here we can see the displacement values by clicking on various nodes. Now we can see the various shear and the shear and movement diagrams by going to display force stresses diagram. Select force, select the shear to click on apply. This is the shear diagram and this will be the movement diagram. Now click on OK. Now we will run the design. Select concrete frame design, select view preferences. Here check whether the respective IS code is set or not. Here it is set, so we will click on OK. Now we will run the design by going to concrete frame design. Select, go to start design check. Wait as the software runs the design. Check. OK. I want to reiterate. Yes, reiterate. So here the software is an evaluation version. So there is a problem in the reiteration function. So now if six frames will fail, so we will select no and verify whether all members are passed or not. Thus we will get the result. Okay, here. So now select no. Now verify whether all members passed the design check or not. Go to concrete frame design. Verify all members passed. All concrete frames passed the design check. So here these are the longitudinal reinforcement values which we can see here. Okay, now we will do the seismic analysis under the response spectrum function. So we will unlock the model, and now we will add the response spectrum function by going to functions, selecting response spectrum, selecting IS 1893 2002, click on add new function. Here give the name as response spectrum. The seismic zone factor is 0.1 as we determined earlier. Soil type is of 2. Leave the values as it is. Now click on OK. Click on OK as we have defined the response spectrum function. OK. Now we will do the now we'll go to load cases and add the response spectrum load case. Here give the name as response spectrum, load case type as response spectrum, add acceleration value u1. Here select the response spectrum. The scale factor the formula of scale factor is equals to I into G by 2R. Here the value of I, importance factor, is 1. G, the value of G is the acceleration whose unit is mm per second square. So the value of G will be 9801, and the value of response reduction factor is 3. So the value of scale factor will be 9801 divided by 1 into 9801 divided by 6. So the scale factor value which we get is 1633.5. Now click on add another load type in the y direction. Here select the load as u2. Here select a response spectrum, and here give the value as 1633.5 as scale factor value. Now here select the CQC3. Model damping is constant at 0.05. If it is not in your model, then fix it to 0.05. Now click on OK. Now click on OK. Now we will run the analysis. Okay, so I have done one mistake here. I will again cancel the analysis as I have run the live loads and dead loads also here. First I will select run, do not run. So I will again unlock the model. Click on OK. Go to analyze, select set load cases to run. Here select the dead load, select run, do not run. Sorry. Here select the model run, do not run, dead load run, do not run, live load, seismic run. response spectrum, run. Dead load and live load are not run, other all elements are run. So now again I will do the analysis. Now the analysis has been done. We can see the displacement values here. Now we will run the design check. Concrete pre-design U preferences at 456 to 2000. Click on OK. Now start the design check. OK. Click on OK. Wait as the design check is being done. It is taking a bit time. Here 14 members failed. Yes, I want to reiterate. Okay. Okay. Now we will check whether all members passed the design check or not. Go to concrete frame design, click on verify all members passed. All concrete frames passed the design check. Okay. Here are the longitudinal reinforcement values given here. Now we will run the seismic analysis under the time history function. So first we will unlock the model, click on OK, go to define, select the functions, go to time history. Here select from file, as we are going to add the time history function of the Boots 2001 earthquake and we have its time history file. So select from file and click on add new function. Here give the name as time history. Give select browse. We will select the file. The file has been added. Here select fix format. Wait as the graph changes. Now here we will view the file. Here 1 2 3 4 5 6 7 8 9. 1 2 3 4 5 6 7 8 9. first 9 lines are left as it is. So here that is are of no use. So here we will skip 9 lines, and the number of points per line we want are 1. Okay, then click on OK. Now so we have added, click on select that and give modify show function data. Here give the name the name as time history. Now click on OK. Click on OK. Now we will go to the load case and create a load case for time history. Here we will delete response spectrum as we are using time history. OK. Add new case. OK. So here we will do one thing. In the seismic, we will select only x direction as the time history acceleration is only present in the x direction. So we will go to load patterns, select seismic load, modify lateral load. Here we will select only the x direction, then click on OK. Then click on OK. Now we will go to the load cases, delete the response spectrum, add the time history function, select time history, click on add, load pattern as acceleration u1, function as time history, scale factor as 1633.5 as discussed before. Rest values will be left as it is. Now click on OK. Click on OK again. Now go to analyze, set load cases to run seismic and time history. OK. We will run this combination. Click on run now. Wait as the analysis is being run. So now here we can get the different displacement values at different nodes by selecting the nodes. We can also refer to the diagrams by going to of shear and bending by going to display force stresses, frame spheres, shear 1 apply, on OK. Here select time history, apply. Here the shear force and bending moment diagrams will be different as the acceleration occurs only in the x direction. So now click on OK. Now we will run the design check on our model. Select concrete frame design, select view preferences as code is set to default. Click on design, start design check. Some design load combinations of design we ignore. OK. Yes. Okay. The design check has been done again. So first we'll verify whether all members pass the design check or not. Verify all members. All concrete frames pass the design check. Okay. So here are the longitudinal reinforcement values shown. Select the pen to view proper values. Okay. Now we can also generate a project report by double clicking the summary report. The report includes the frame section values as well as the load application values and the analysis values. It is taking a bit time to generate the report. The report has been generated and it has contained the value which I discussed. So finally we have completed the analysis and design of seismic resistant buildings under